Hello everyone. We have been speaking about force and the laws of motion. We saw the two types of forces and how they act on different objects. We now come to the other part of the chapter, the laws of motion. Today we will study about the first law of motion. Here we can see Galileo and Newton, the two pioneers who have made these laws possible. Firstly, let us see what Galileo worked on. Galileo observed that inclined planes proved to be very useful for the study of motion. An inclined plane looks like this, much like a slide you see in parks. He placed two inclined planes like you can see here. He studied using a marble. He saw that when a marble rolls down an inclined plane, its velocity increases. We can relate this to the fact that when we slide down a slide, the velocity of our body increases than what it was when we were simply walking. He also studied that when a marble goes up an inclined plane, its velocity decreases. Another of his observations is also seen here. He saw that when the two inclined planes were placed at such an angle to each other, the marble that slipped down one of them climbed the other to reach the same height. Here we can see that the marble which went down on the incline on the left side went up the one on the right to the same height. It is important to note that this only happens when the angle of inclination of the plane is simple. How can we say this in a concise manner? If the inclination of the plane on both sides are equal, then the marble will climb the same distance that it covered while rolling down. We will soon understand the significance of all of his observations. Galileo also made some modifications to his experiments, which we will see now. The first modification that Galileo made to this experiment was to decrease the angle of inclination for one of the planes. Here you can see that the plane on the left has the same inclination as before, but the one on the right is less inclined. Let's see how the marble behaves here. The marble again rolls down the plane on the left and starts to climb the one on the right. Here you will notice that it has reached the top of the incline. In the previous example, we saw that the marble travels the same distance on both the inclines. But here you can see that the marble travels more on the right one. We can put it in a sentence like this. If the angle of inclination of one plane would decrease, then the marble would travel for distance till it reaches the original height. Let's see the next modification to this experiment. On the left, we have the plane with the same inclination as before. But on the right, we have a horizontal surface. A horizontal surface has zero inclination. It is not raised at all. So when the marble rolls down a plane, it continues traveling on the horizontal surface. Galileo thought that the marble will travel forever trying to reach the original height. But we know that the original height will not be reached because the horizontal surface is not an inclined plane. So, if one plane were made horizontal, the marble would continue to travel forever, trying to reach the same height that it was released from. If the marble is said to continue in one direction forever, you would think that there were unbalanced forces at play here. Let us see if this is true. An unbalanced force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. What this sentence is trying to say is that the marble does not need an unbalanced force to continue its uniform motion, but the marble needs a balanced force to change its motion. So when the marble was rolling down one plane and climbing up the other, there were unbalanced forces involved in the motion. But when the marble continues to roll on a horizontal surface, it is said to have zero balanced forces. This means that there are no balanced forces and the marble can continue to move forever. However, zero balanced forces is not achievable because of the presence of frictional force, which is acting opposite in the direction of motion. We have seen that frictional force is generated between the floor and the bottom surface of any object. So in this case, the marble and the floor are generating some frictional force. The direction of the frictional force is opposite to that of the motion of the marble. Thus, the marble will not continue to move forever. it will stop at a certain place. However, there are ways to reduce friction. When drawers do not open properly, it is due to frictional force being generated. So the hinges of the drawers are lubricated. Frictional forces can be reduced by lubrication. Lubricants can be creams, oils, etc. So if the floor is covered with the lubricant, the marble will experience less frictional force. However, it is not possible to completely eliminate friction. Coming to the second pioneer, Newton studied the experiments conducted by Galileo and made his own conclusion. Newton made the three laws of motion. These three laws are extremely important to understand daily life as well as make machines in industries. So today we will look at the first law. The first law says that an object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. Before explaining this, I will show another definition. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. To understand this, we will take a very funny example. Imagine your cat was sleeping peacefully. He can be said to be at a state of inertia. It is considered as an undisturbed object and is at rest. But if you wake it up, it will be disturbed. In terms of physics, you have applied a force on the cat, due to which its state of inertia has been changed. So the first law says that when an object in rest or in uniform motion changes, it is due to an applied force. An applied force is usually external. Now we will go into some real life examples of how we see the first law in a real life. To understand the three kinds of example, we will take the instance of a motorcycle. Imagine you're sitting on the motorcycle. Assume you are going somewhere. What do you do when you suddenly see a car approaching in front of you? You suddenly apply a brake. What is the one thing you will observe when you apply a brake? The vehicle comes to a stop by slowing down, but something happens to your body. Have you guessed it yet? When the brakes are applied, our body tends to continue in the same state of motion due to inertia. Recall that inertia can be a state of rest as well as uniform motion. Uniform motion was being exhibited when you were on the motorcycle. So when you suddenly applied the brakes, your body tried to retain the motion by moving forward. An external force in form of the brakes was applied to disturb your inertia. As a result of this, your body moved forward. Now that the road is clear, you start your motorcycle again. The engine starts and the vehicle starts to move. What happens to your body in such a case? When a vehicle starts moving, your body continues to remain at rest due to inertia. When the motorcycle was not moving, your body was also at rest. But when the motorcycle started moving, it put a force on your body to change its motion. As a result of this, our body moves backward when it experiences a force like this. Lastly, if the motorcycle takes a sharp turn, the body will fall sideways. When we take a turn, there is a change in the direction of motion due to which the body falls outwards. So when you are taking a right turn, we will feel our body leaning towards the left because it is opposing the change in direction of motion by trying to move in the opposite direction. When a vehicle makes a sharp turn at a high speed, the body gets thrown to one side due to inertia. So all of these three consequences are due to the presence of inertia. These examples are good to study about inertia since they are relatable and relevant to real life. Let's see another classical example of how inertia works. The game shown in the picture is carom. If you stack all the pieces of the carom at the center as visible in the picture and hit it with a coin, you will see that the lowest coin will get displaced, but the coins on top of it will fall back on the table just the way they were. All the coins in the stack were at a position of rest. But due to the coin that was aimed at the stack, the inertia of the lowest coin was disturbed. As a result of this, it was displaced. But the coins above in the stack retain their inertia and stay in their structure. They are still at rest. So today we studied about the first law of motion, which is also called the law of inertia. The first law of motion is called the law of inertia because it says that an object at rest or in constant motion changes only due to an external force. Thank you, and I hope you've gained something from it.